welcome to another video for the Unit 9 test review. For number 1, what we're going to do is complete the statement and then write the postulate that we used for the statement. So, in number 1, I have the measurement of blank plus the measurement of Ln equals the measurement of blank. In the picture, I see two types of tick marks, a single and a double, and it looks like the double is with Ln, which leaves the single tick mark to be KL. So the measure of KL. When we add those two segments together, I get one longer segment from K to N. This postulate is the segment addition postulate. Number 2, the measurement of some angle plus the measurement of some other angle is the measurement of WXZ. WXZ is this angle from W to X to Z. And I can see that I have two angles marked there in the middle that combined create this bigger one. The one on the left, let's name it angle WXY. And then the one on the right, let's name it YXZ. The postulate is called angle addition. Number 3, we got some addition of angles happening again. Let's take a look. Measurement of some angle plus a measurement of another angle equals 180. In the picture, I have two angles labeled. The angle on the right, or the left, let's label it GHI. And the angle on the right, let's name it IHJ. When I add those two angles, I get 180. That's a straight line. The postulate is the linear pair postulate. Lastly, we have an angle being congruent to another angle. Let's take a look at the image. I've got two angles marked with the same arch, so we've got angle VWX congruent to angle ZW. This is the vertical angle postulate. Alright, let's do a little algebra with our geometry. In number 5, we have angle ABC forming a linear pair with angle CBD. Whoops. Let's use the linear pair postulate to determine the value of x. The linear pair postulate states that when we add the two angles, it equals 180. So let's see what two angles we have. We have angle ABC, which is 5x, and CBD, which is 13x plus 36. X plus 13x plus 36 equals 180. Zoom back in. Try to zoom back in. There we go. Alright, let's solve. The first thing that I'm going to do after I color code it is combine some like terms. What I'd like to combine on the left side are my x's. I can combine 5x and 13x. 5x plus 13x is 18x. And we bring everything else down. Alright. Now that we've combined all possible like terms on the same side, let's work on getting x by itself. The first thing that we have to do is subtract 36 in order to undo the plus 36. On the left side, we have 18x equals. On the right, 180 minus 36 is 144. To finish this up, we're going to divide both sides by 18. 18 divided by 18 is 1, which is what we wanted. We wanted a 1x, so x equals 144 divided by 18 is 8. Fantastic. Let's try number 6. Number 6, I have if angle RQT is 136 degrees, determine the measurement of RQS and SQT. Alright, well, RQT is that large angle. What we're going to do here is use the angle addition postulate. That's what we've done. Angle addition. Alright, so what the angle addition postulate tells us is we can add two smaller angles to form the larger one. So we have 8x minus 4 plus 4x minus 20 equals 136. And RQT is at 136 degrees. Alright, let's solve for x, and then we can plug it back in to find what the angles are on their own. The first thing I notice here is that we have several like terms on the left side. Let's combine them. I notice that we have x's, 8x and plus 4x. I also notice regular numbers, negative 4 and minus 20. Whoops, it's plus 20, right? Cool. I'm so glad I just caught that. Oh, all right, let's combine. 8x plus 4x is 12x, and negative 4 plus 20 is 16. So we get 12x plus 16, and it still equals 136. Alright, next, let's work on getting x by itself. I'm going to subtract 16 from both sides first. So on the left, we have 12x equals 136 minus 16 is 120. And then I get to finish up by dividing both sides by 12. So we've got x equals 10, which is fantastic, but we need to find the value of the two angles. Let's start with angle RQS. So RQS is 8x minus 4. We found that x is 10, so instead of x, I'm going to plug in 10. 8 times 10 is 80, minus 4 is 76. Now let's do the same thing for measure of angle SQT. That's this green one. This one started off as 4x plus 20. We're going to plug in x, which is 10. 4 times 10 is 40, plus 20 is 60 degrees. And if you do some quick math in your head, 76 plus 60 does in fact give us 136. Fantastic. Numbers 7 and 8, what we're just going to do is write down some congruency statements, where we're not going to be writing any proofs, just congruency statements. Alright, let's begin. In number 7, I feel like starting with the sides. This side, and this side. We got side A, R, congruent to side Y, R. Let's do the angles next. We've got angle AMR, congruent congruent to angle YMR. Alright, let's do the same thing for number 8. I've got double ticks. Let's match them up. I got ZY, and I've got MY. Let's do the angles. I'm going to call the one on the left ZYS, and on the right, I'm going to call it MYA. Fantastic. Now for number 9, or 9 through 11, we're going to determine if there's enough information to prove that each pair is congruent by side, 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 angle, or angle, side, angle. We're going to write the congruent statements to justify our reasoning. So number 9, is ABC congruent to ADC? In the figure shown, ABC and ADC are isosceles triangles with bases DC and BC, and angle BAC is congruent to CAD. Are they congruent? If so, by what? Okay, let's start by just marking that angle we were given, that BAC is congruent to CAD. That's an angle, right? Whoops. That's the angle here and here. Okay, now, an isosceles triangle is a triangle that has two congruent angles and two congruent sides attached to its base. The base of the triangle on top is BC, and the base of the triangle on the bottom is DC. I'm going to use the magic of technology to rotate this drawing to match the triangle. Okay, that means the top triangle has these two sides congruent, and the bottom triangle has the same idea. I have already marked this side of the bottom triangle, and if the two sides connected to the base are the same, then this must be also one tick mark. So each triangle has a side, two sides, and an angle. But is it side, angle, side? Let's see. In order to know if this is side, angle, side, the angle must be touching both sides. So the angle of the top triangle, okay, touches that side and that side. All right, so we have side, angle, side in the top triangle. In the bottom triangle, the angle also touches both sides. So yes, side, angle, side. Fantastic. What about number 10? Is MAR congruent to GEO? Well, I have a 3mm side on each triangle. I have a 4mm side on each triangle, and I have a side marked with a tick mark on each triangle. Are they congruent? Yes. They are congruent by side, side, side. Let's prove it. Alright, here we go. Let's start with the 3mm side. We have MA congruent to GE. The reason it was a given side, we have the 4mm sides. I'll do AR congruent to EO. Another given side. And lastly, we have that single tick side. RM congruent to OG, yet another given side. So, we can conclude that angle MA, triangle MAR, is in fact congruent to triangle GEO by side, side, side. Well, what about number 11? Is MAR congruent to MYR? Well, let's check it out. They both have a single angle, and they both have a double angle. But that's not enough information for us to say if they're congruent. So we might need to say no here. However, I see something that I can mark that each triangle also has. Each triangle here shares the middle side. So, are these triangles congruent to each other now? Yes, they are congruent to each other by angle side angle. Let's prove it. Let's start with the single angle. I have angle AMR congruent to angle YMR. And this was a given angle. We have the middle side. This is funny. We have MR congruent to MR. And this was the reflexive. Whoa, that's not an I. Reflexive property, which is a side. And then we've got that second angle with the double arches. Let's call it angle MRA and angle Y. Whoa. No, MRY. That's what I wanted to do. And this was another given angle. So our two triangles are in fact congruent. Triangle MAR is congruent to triangle MYR by angle side angle. Alright. Number 12, some multiple choice. Which congruent statements can be used to show that triangle KML is congruent to triangle RTS by the angle side angle congruence theorem? Okay, now these two triangles only have a side labeled, so I need two angles. I can immediately cross off options A and B because those are sides. Now C and D start the same. Angle K is congruent to angle R, so let's mark it. Angle K is congruent to angle R. Now before I even look at the other options, I'm just going to mark the other angles we need for angle side. Angle side. We need another angle here. Angle, side, angle. So we have angle M and T. That exists in letter C. Number 13. Which congruent statements, I zoomed in too much, there we go, can be used to show that these two triangles are congruent by side angle side? Let's try that again. Oh, I still moved it. You see that? It's off. There we go. Still doing it. Thank you for bearing with me. Alright, well, take a look at 13. What did I give you? Angles or sides? I'm going to give up on this. I give up. That's fine. I give you an angle. So, we need two sides. Which means we can cross off C and B. We don't need any angles. A and B start the same way. KM is congruent to RT. Let's mark it. KM is congruent to RT. Which means we need another side. Let's just look at these angles. We have a side. We have an angle, which means we need a second side right there. Side angle. So we need a KL and an RS. KLRS, that's letter A. Perfect. 14. Suppose angle M is congruent to angle Y. That's not on the picture. Let's mark it. Angle M, angle Y. What information would you need to conclude that triangle MAR is congruent to YRA by side angle side? Okay, so something I like to do when I see these overlapping triangles is to separate. And this is what I mean. One of the triangles is right here. I'm going to draw it. M, A, gonna mark that out. The other triangle I see is YRA. I'm gonna draw it here as well. It's not gonna be perfect, but that's okay. It's just to help me see. Now, I like to do this. I'm gonna give those triangles a shot again, as I tell you why I like to do this. When triangles overlap, sometimes it's hard for me and probably some other people to see the actual triangle, to recognize the side angle side, to label things correctly. So I like to redraw them, and it makes it easier for me to envision what I'm supposed to be doing. If that doesn't help you, don't do it, but I am going to label both images and do what works best for you. Okay, so we have an angle, which means we need two sides. Let's start with triangle MAR. Let's label this side, and let's label that side. So in triangle YRA, we can label this side, and we could label that side. SAS. That angle is right there. L is already given to us. Okay, let's write down the congruency statements. We would need AN to be congruent to RY, and we would also need R congruent to Y. Alright, well, let's try that again in number 15. I'm again going to separate the triangles, but we're going to have a different given statement and a different conclusion. In number 15, I want to suppose that MA is congruent to YR. Let's mark it. And AR. What other information would we need to conclude that triangle MAR is congruent to YRA with angle side angle? Let's draw the triangles. So I can give them this. Angle side angle means I would like two angles to surround each side. So let's put an angle on the top of each side and on the bottom of each side. This was the hard part for me when I was a student, seeing this, knowing to use all of angle A and all of angle R. So let's write down the congruency statements. The top angle, let's name the one on the left angle AMR, and the one on the right, let's label it RYA. For the angles on the bottom, for the left image, I'm going to go with MAR, and that's congruent to YRA. If the image that I've been drawing on the right side doesn't help you, don't draw it for yourself. Don't confuse yourself. If you're able to understand the triangles with the way it's printed, kudos, do that. But I know there's at least a few of you that were like me and really will benefit from splitting up those triangles. Let's continue. Number 16. Suppose NR is congruent to YA. What else do we need to conclude that MAR and YRA are congruent using side, side, side? Let's draw the two triangles. We have MR congruent to YA. We were given that. So we're missing that MA is congruent to YR. And we're missing that AR is congruent to AR. Number 17. Suppose AB is a perpendicular bisector of CD. Let's label the image. Perpendicular means where the lines meet, it creates a 90-degree angle. Well, we got two 90-degree angles. A bisector means we're cutting something in half, which means CD splits into two same measurements. The congruent line segments will create our CD and DB, and the angles we create are ABC and ABD. Number 18. Suppose ER is a perpendicular bisector of GO. Are there congruent triangles? Explain your reason. Alright. Perpendicular. That means creating 90-degree angles. So there should be two 90-degree angles right here. Perfect. Angle. Bisector splits something in half. So, do we have congruent triangles? We do. Because I can mark something else. What else can I mark? I can mark the middle. That's the proper. So we are congruent by side angles. We have GE congruent to OE because ER bisects GO. We have two angles that are congruent. We have REG and REO because ER is perpendicular to the GO. And lastly, we have that RE is congruent to RE because of the reflexive property. What? I lost my flow of writing. The reflexive. There we go. Beautiful. Is this our last one? Sure is. For the following figure, Miranda determines that DF and AC are congruent. They also measure that angle C and angle F and determines they're congruent. They then conclude that the triangles are congruent by side angle side. Is that enough information? Is Miranda correct? Well, let's see. We have that DF is congruent to AC. Sure. I have that angle C is congruent to angle F. Right? Yeah. But she's missing something. She's missing a side. She wants side angle side. And yeah, I get it. I can see that they both have three boxes, but she never wrote that or determined that. Just like how she determined DF and AC were congruent because they take up two grid spaces, she should have done the same for EF and CB. So, no. She, or Miranda is missing a side. She is missing CB congruent to EF. No, let's call it FE. Alright. I hope this was helpful. If you have any questions, please make sure to ask myself or whoever else is helping you out in math. Otherwise, have a wonderful rest of whatever day it is for you. Bye!